Okay, now I would like to explain some problems and transients. Okay, this is the given problem. Okay, determine IL of 0 plus, this is time constant, IL of t and VL of t. So this is the given circuit here. This one 40 ohm resistor, supply voltage 24 volts, and it is 10 ohm resistor, and it is 5 henries. So find the IL of 0 plus. So inductor current at t equals to 0 plus. So next it is tau. So it is called time constant. So tau equals to formula L by R. So here we have to find equivalent inductance value and equivalent resistance value. Next, by using tau equals to L by R formula, we have to find the time constant. Next one, IL of t. So IL of t means the current equation from t equals to 0 to infinity. Next, VL of t, the voltage equation from t equals to 0 to infinity. Okay, here circuit total operating time minus infinity to plus infinity t plus infinity. At t equals to 0, switch open. Here in the circuit, the switch open at t equals to 0. So it means from t equals to minus infinity to t equals to 0 minus. Switch position, closed position. In that case, supply connected to circuit. So next, from t equals to 0 plus to infinity. Switch position, open position. So in this case, the supply disconnected from the circuit. So here from t equals to minus infinity to 0 minus, supply connected to circuit, and from t equals to 0 plus to infinity, supply disconnected from the circuit. So now we have to find these four: IL of 0 plus, tau, IL of t, and VL of t. So first one, it is series RL circuit. So IL of 0 minus equals to IL of 0 plus equals to IL of 0. So initial condition of the inductor. So draw a t equals to 0 minus circuit. So t equals to 0 minus, switch position, closed position. So why? Because the switch open at t equals to 0, t equals to 0 minus means, so just before switching operation. So just before switching operation, switch position, closed position. So this is the circuit at t equals to 0 minus, here switch closed position. Okay, next inductor. So here supply connected to circuit at t equals to minus infinity. So at t equals to minus infinity, inductor acts as open circuit. So next t equals to 0 minus. So after a long time, the inductor acts as short circuit. Here at t equals to 0 minus, inductor acts as short circuit. So this is the equivalent circuit. So find IL of 0 minus, inductor current value. So 10 ohms current equals to inductor current value. So 10 ohms current value. So voltage across the 10 ohms by resistance value. Here 24 volts connected across the 10 ohms. So IL of 0 minus equals to 24 by 10. These two elements are connected in parallel connection. So voltage by resistance equals to current 24 by 10. It equals to 2.4 amperes. At t equals to 0 minus, current equals to 2.4 amperes. So inductor initial current IL of 0 minus equals to IL of 0 plus equals to IL of 0. So it equals to 2.4 amperes. Okay, first one IL of 0 plus value 2.4 amperes. So next find equation. So from t equals to 0 to infinity. So t equals to 0 to infinity, switch position, open position. Okay, supply disconnected from the circuit. Okay, this is the circuit from t equals to 0 to infinity. Here supply disconnected. So the equivalent circuit of the circuit is this one. Supply disconnected. So we can draw the circuit like this. So next apply KVL. KVL equation. So assume current direction, here clockwise direction, current equals to I of t. So equation minus 40 into I of t minus 10 into I of t minus 5 into di by dt equals to 0. So voltage across the resistor, I into R formula, so 40 into I. Here this is also resistor, so 10 into I. So next voltage across the inductor formula, L into di by dt. L equals to 5 into di by dt. Here polarities plus to minus, so minus 40 into I of t. Here plus 2 minus, minus 10 into I of t. Here plus 2 minus, minus 5 into di by dt equals to 0. Or it equals to 50 into I plus 5 into di by dt equals to 0. Or di by dt plus 10 into I equals to 0. Okay, standard differential equation, di by dt plus pi equals to q. Here p value 10, q value equals to 0. So next find complementary function. Cf equals to formula c into e power minus pt. Here p value 10. So C into e power minus 10 into t. Next pi value equals to 0. So why? Because here q equals to 0, so automatically the pi value becomes 0. So next total response I of t equals to Cf plus pi. So I of t equals to C into e power minus 10 into t. Okay, this is the current expression. So next to find this constant value. So by using initial current. Here initial current I of 0 plus value equals to 2.4 amperes. Okay, now solve to t equals to 0 in the above equation. So I of 0 equals to C into e power 0 and I of 0 value equals to 2.4. So I of 0 equals to C into e power 0, it equals to 2.4, e power 0 equals to 1, finally C value 2.4. Okay, substitute C in I of t expression, we get I of t equals to 2.4 into e power minus 10 into t. 2.4 into e power minus 10 into t amperes. So time constant equals to L by R from t equals to 0 plus to infinity. This is the circuit. So in the circuit the equivalent resistance value. So 40 plus 10, 50. Two elements connection, series connection. So 40 plus 10 equals to 50 resistance value and inductance value equals to 5. L by R means 5 by 50. So it equals to 1 by 10. So time constant equals to 1 by 10 seconds. So next voltage across the inductor VL of t equals to L into dI by dt. L equals to 5 d by dt of I of t. I of t equals to 2.4 into 10 e power minus 10 into t. So finally the voltage across the inductor, okay, 5 into 2 e power minus 80 differentiation minus a into e power minus 80. So minus 10 into e power minus 10 into t, it equals to minus 120 e power minus 10 into t volts. So voltage across the inductor expression. Okay, next problem. So for the circuit shown in figure, the switch is closed for a long time and it is open at t equals to 0. So determine Vc of 0 plus I of 0 plus. And also here find I of t, Ic of t and Vc of t. So first find a t equals to 0 minus current voltage value. This is RC circuit. In RC circuit, Vc of 0 minus equals to Vc of 0 plus. So t equals to 0 minus circuit. Okay, here switch open at t equals to 0. So it means from t equals to minus infinity to t equals to 0 minus. Switch position, closed position, and t equals to 0 plus to t equals to infinity, switch position, open position. Here at t equals to 0 minus, switch position, closed position. So circuit becomes like this, and capacitor. Here supply connected at t equals to minus infinity. So at t equals to minus infinity, inductor acts as short circuit. And at t equals to 0 minus. So t equals to minus infinity to t equals to 0 minus, time approximately equals to infinite. So after infinite time, the inductor acts as open circuit. So here inductor acts as open circuit. So find the voltage across this open circuit. It equals to Vc of 0 minus. So here this is open circuit. So 500 ohms current value equals to 0. The voltage across the 2 kilo ohms equals to open circuit voltage. It equals to Vc of 0 minus. So apply voltage division. Vc of 0 minus equals to total voltage equals to 50 into same resistance value 2000 by 2000 plus 500. It equals to 40 volts. This is Vc of 0 minus. So capacitor case initial condition Vc of 0 minus equals to Vc of 0 plus. So it equals to 40 volts. So here capacitor voltage value, initial voltage value equals to 40. So next one, current, find the current. Set t equals to 0 plus current value. So in this circuit, I of 0 minus value not equals to I of 0 plus. So directly we have to find I of 0 plus value by using Vc of 0 plus value. So t equals to 0 plus circuit. At t equals to 0 plus, switch open. Okay, switch open. So this 500 ohms open and source also open. So in that case, the circuit becomes like this. So 2 kilo ohms, next 500 ohms, next one capacitor. So it is 1 microfarads, not 0.1, 1 microfarads capacitance value. Okay, so we know that Vc of 0 minus equals to Vc of 0 plus. This is circuit at t equals to 0 plus. So Vc of 0 plus value equals to 40 volts. Vc of 0 plus value 40 volts. Next current equals to voltage by resistance. Here voltage across the capacitor equals to 40 volts. So 40 by total resistance 40 by 500 plus 2000. So I of 0 plus value equals to 16 milliamperes. So current equals to voltage by resistance. So capacitor stores the voltage. That voltage value equals to 40 volts. So 40 by total resistance. 40 by 2500. It is 2 kilo ohms. 2 into 10 to the power of 3. So 2000 plus 500. 2500. 40 by 2500 equals to 16 milliamperes. I of 0 plus value. Initial current. So next to find current expression I of t. So to find current expression, so we have to draw the circuit diagram from t equals to 0 plus to infinity. Okay, this is the circuit diagram from t equals to 0 plus to infinity. So assume current direction clockwise direction. So next apply KVL. So plus to minus 2000 into I of t minus 500 into I of t minus VC equals to 1 by C integral I of t into dt. Here capacitance value 1 microfarads, not 0.1. This is 1 microfarads. So 1 by 1 into 10 to the power of minus 6 integral I into dt. So equation minus 2000 into I minus 500 into I minus 1 by C integral I into dt. Here I value 1 microfarads. So micro means 10 to the power of minus 6. So next by differentiating with respect to t, here 2000 minus 500. Okay, minus 2000 minus 500 I equals to minus 2500 I. Okay, minus 2500 I. By differentiating we get minus 2500 dA by dt. Next differentiation integration cancel. Minus I by 1 into 10 to the power of minus 6 equals to 0. Or it equals to di by dt plus I by 1 into 10 to the power of minus 6 into 2500 equals to 0. Or di by dt plus I by 2.5 into 10 to the power of minus 3 equals to 0. Okay, next the standard differential equation di by dt plus p into I equals to q. So here q value equals to 0 and p value 1 by 2.5 into 10 to the power of minus 3. Next complementary function CF equals to formula C into e power minus pt. So C into e power minus 1 by 2.5 into 10 to the power of minus 3 into t. Pi value, here q value 0, so automatically the Pi equals to 0. Next the current expression I of t equals to Cf plus Pi. Here Cf equals to C into e power minus 1 by 2.5 into 10 to the power of minus 3 into t. Pi equals to 0. So this is the current expression. So next to find this constant value, apply initial condition. So initial current value I of 0 plus value equals to 16 milliamperes. So substitute t equals to 0 in this equation. I of 0 equals to C into e power 0. I of 0 value 16 milliamperes, 16 into 10 to the power of minus 3. E power 0 equals to 1. So C value 16 into 10 to the power of minus 3. Okay, next to substitute C value in I of t expression. We get I of t equals to 16 into 10 to the power of minus 3 e power minus 1 by 2.5 into 10 to the power of minus 3 into t. So next to find Vc of t, voltage across the capacitor. Okay, formula Vc of t equals to 1 by C integral I of t into dt. C value 1 microfarad. So 1 by 1 into 10 to the power of minus 6 integral I of t. Okay, this expression 16 into 10 to the power of minus 3 minus 1 by 2.5 into 10 to the power of minus 3 into t. Finally Vc of t equals to minus 40 e power minus t by 2.5 into 10 to the power of minus 3 volts. Okay, by integrating this expression, so finally we get the voltage across the capacitor expression.